Hey there, ever looked at a super complex plumbing drawing and just thought, how in the world does this become, well, plumbing? If so, you're in exactly the right place. Today we're going to build a full step-by-step execution plan, turning that blueprint into a working reality. Just think of me as your senior engineer, walking you through it all right here.
Okay, here's our roadmap. We're going to tackle this just like a real project, from start to finish. First, we have to learn the language of the drawings. Then, we turn that understanding into a solid plan and figure out what materials we need. After that, it's all about getting on site and building it right, testing everything, and finally, handing over a finished project. Let's dive in.
All right, first things first. Before we can even think about touching a pipe, we have to understand what the drawing's telling us. Think of it as the building's entire circulatory system. Every single line, every symbol, it all has a meaning and a purpose. We always start with drainage. Why? Because gravity is the boss on this job. So your first task is to find the one fixture, a sink, a toilet, whatever, that's the furthest away from where the pipes leave the building. You trace that line all the way back. That path sets your main slope and your invert level, which is just the lowest point inside that pipe. If you get that backbone right, everything else can flow into it correctly. Now this is where the physics really kicks in. Look at the numbers. That big 8-inch main for all the sewage, it can move a ton of volume, so it only needs a gentle 1% slope to keep things flowing. But a 4-inch line coming from a toilet, that needs a steeper 2% slope to get enough velocity to push solid waste clear. Get this wrong, and you're not just failing an inspection, you're basically building a future clog into the system from day one. These slopes are absolutely non-negotiable. Next up are the vent lines. Now, these are the unsung heroes of the plumbing world. It's easy to overlook them, but they're just as important as the drain pipes themselves. They're like a snorkel for your drainage system. They let air in, which equalizes the pressure. Without that, every flush would create a vacuum, and that's when things get ugly. And here's what ugly looks like. Trap siphonage. You know that little U-shaped pipe under your sink? That's a P-trap. The water that sits there is the only thing stopping foul and, potentially dangerous sewer gases from coming up your drain and into the building. When water rushes down a pipe without a vent, it creates a vacuum that can suck that water barrier right out of the trap. Vents prevent that vacuum. Simple as that. And finally, we map out the arteries, the cold and hot water supply lines. This is the clean, pressurized water coming in. We trace the routes to every fixture, checking pipe sizes to make sure there's going to be enough pressure everywhere. And maybe most importantly, we make sure there is a safe separation, an air gap or a backflow preventer, so there is absolutely no chance of the clean water ever getting contaminated by the drainage system. So, we can read the map. Now it's time to chart the course. We're going to translate all that information from the drawings into a master plan. And this isn't just a simple to-do list, it's a strategic sequence, an order of operations that will make or break the installation. This sequence is your recipe for a smooth project, and the order is everything. You have to start with the main drain lines because they're dictated by gravity and slope. Everything else gets built around them. Just imagine trying to fit a sloped drain pipe after all the water lines are already in place. It's a nightmare. You'd be tearing out finished work. Drains first, then vents, then water supply. Following this order saves you from a world of headaches and rework. And remember, we're not the only ones working in the building, right? The space above the ceiling is a war zone. You've got massive HVAC ducts, big firefighting pipes, and trays packed with electrical cables. Your pipes have to navigate all that. If you look at the drawing and see a potential conflict, don't guess. Don't just try to make it fit. Stop. Raise a formal request for information, an RFI, and get a clear decision. Okay, the plan is solid. Now it's time to get our shopping list together. And this means we have to meticulously account for every single part and piece we need to bring this thing to life. This is your bill of quantities, or BOQ. It has to be perfect. You're literally going to trace every single line on that drawing and measure it. How many feet of 4-inch pipe? How many toilets? How many supports? Every fitting, every valve. A mistake here isn't just an extra trip to the supply house. We're talking project delays and blown budgets, all because somebody miscounted a few fittings. Good procurement is about playing chess, not checkers. You have to think a few moves ahead. What items take a long time to get? Custom grease traps, special manhole covers. Order them now. Don't wait. And check your supplier's quality certificates before you place the order. Also, think about prefabrication. Building a complex pipe assembly in a controlled workshop is almost always faster, safer, and higher quality than trying to piece it together on site. All right, let's get our boots on the ground. We're on site now. This is where the plan becomes reality, and where our precision in both quality and safety is absolutely non-negotiable. I mean everything. Okay, let's get this straight, because it's crucial. QA and QC are not the same thing. Think of it this way. Quality assurance, QA, is proactive. It's about the process. It's about making sure your team has the right training and procedures to prevent mistakes in the first place. Quality control, QC, is reactive. It's about inspecting the product, the finished work, to find any defects that might have slipped through. You need both, period. These are the checks you're going to live and breathe on site. You'll have a spirit level in your hand constantly, verifying every single pipe's slope. You'll pressurize the water lines to test for leaks. And at every key stage, you'll submit a formal inspection request to get the consultant to sign off on your work. This creates a documented trail that proves you're building to a high standard. And I want to be crystal clear about this. Safety is not about ticking boxes. It is not optional. If you're welding, you get a hot work permit. If you're going into a manhole, you get a confined space permit. These aren't just pieces of paper. These are the procedures that make sure you and your entire crew go home safe at the end of every single day. So, the whole system is installed. It looks great, but looking good isn't enough. Now comes the moment of truth. We have to put this system through its paces and prove with cold, hard data that it works exactly the way it was designed to. This is basically the final exam. We're going to pump up those water supply lines to 1.5 times their normal working pressure, and then we're going to watch that gauge. It cannot move, not even a tiny bit. For the drainage lines, we cap the system and fill it with water or air to find even the smallest leak. And finally, the simple but critical test. We flush every toilet, run every sink, and make sure it all drains smoothly. No gurgles, no backups. That proves our vents are doing their job. You got to remember this rule in construction. If it's not in writing, it never happened. You need that paper trail. Every single step, from getting the materials approved before you even order them, to getting the shop drawings signed off, to the final testing report, requires a formal approval from the consultant. This process protects you, it protects the client, and it ensures everyone is on the same page. We've made it. We're at the finish line. The system is built, it's been tested, it's been approved, but we're not quite done. The final critical step is to package everything up professionally for the client and for the facility management team that's going to run this building for the next 50 years. Handing over a complete package like this is the mark of a true professional. This isn't just a pile of papers. It's the complete instruction manual for your work. You're providing the as-built drawings that show exactly how it was installed, the maintenance manuals, all the test reports, the warranties, everything they need to operate and maintain the system you just built. This is your legacy on the project. And there it is. We took a 2D drawing, lines on a page, and turned it into a fully functional, 3-dimensional system. You now have the entire playbook. You know how to decode the plan, build the strategy, and execute it on site. So the only real question left is, what are you going to build next?